Okay, right now, in the last class, we have discussed that what are sets, what is the definition of set, what are some important set of numbers, by which notations we can define our set. The next we were discussing about the number of elements in a set A. Number of we can write like number of set in A, number of elements in set A, or we can also like this, the mod, kind of mod sign. Right now, if we see this example, we have A, we have B, and we have C. It is clearly defined that we have three numbers, three elements in set A. So what we can say that number of elements in set A is 3. Proceeding to the null set, or define, or we can say empty set. Both are SM. We can say a set with no element is called a null set, or we can say empty set. They are usually denoted with a kind of fire sign. Let me fire, or we can say a simply curly bracket with no element. Let's have an example. We can say x is set A is x such that x is greater than 5 and x is less than 2 is equal to we have x that is greater than 2 and x less than 2, x greater than 5 and x less than 2. X greater than 5 we have 6, 7, 8, 9 and so on, and x less than 2 is 1, 0, minus 1, but we didn't find the same elements, so 6, 7, 8, 9 and 1, 0, minus 1, they aren't equal. Not even a single element is equal, or we can say that it lies within the range of x, right? So hence it is indicated with null set. Okay, proceeding to the finite set. What does that mean? Finite set is the set which contains some specific and finite number of elements, means whose limit is defined. Let's have an example. We have 1, 2, 3, 4, 5. These are defined. These are limited. They are not infinite. For example, let's take another set. We can say A, B, C, D, E, F, G. So these are some defined sets. Proceeding to the infinite sets. We have those sets which are not finite, those which does not contain a specific and finite number of elements. let's suppose we have 1 3 5 7 9 and this goes on. We do not know where will it going to be and we do not know this. Secondly, if we take a simple 1 2 3 4 5 and so on. So these are indicated as infinite sets. Further we'll discussing equal sets. Those sets who have the same elements. Here we are talking about two sets, set A and set B. Right now they both are empty. We can see that they both are empty, so they are equal sets. We have A, B, C and D in set A, and we have B, C, A and D. Since they are equal as they have the same elements, we are not counting or taking the correspondence. We are not checking its correspondence. We are just checking that set A includes those elements which are also in set B. We can say that A is equal to B when they both are equal. When not, we do not say. We will simply write like this. We use this symbol when not equal. Let me copy this example. We have E right here. So A and B are not equal when not equal. Alright, further we are proceeding to equivalences. That is, two sets A and B are said to be equivalent if A 1 minus 1 correspondence can be established between the elements. We can denote that with A is equivalent to B. How? If we can say its example, we have A equal to A, B, C, D and E, whereas B is equal to two, 3, 5 and 4. And we have another set C, X, Y, Z, U, V. Right? We can say n of that is the number of elements in set A is also equal to number of elements in set B and C, that is 5. 5, 5, 5. So we can say A is equivalent to B, B is equivalent to C, and C is equivalent to A.